Hello. Now I am going to discuss on Thevinins theorem, which is a part of electric circuit theory. Now here is an example circuit. So before going into this, I prefer to view my previous videos on Kirchhoff's laws so that it will be easy for us to distribute the current in the circuit. Yeah, let me go step by step. And this theorem is the easiest theorem to solve, but there are few laws to do in this. Let me go step by step. Now what Thevinins said is, let me assume that we have to find the current flowing through this 4 ohm resistor by using Thevinins theorem. So what is the first step I am going to do is, I am going to remove this 4 ohm resistor according to Thevinins theorem. I am going to remove this 4 ohm resistor from the circuit, and I am going to name this as load resistance, which is 4 ohm. This is the first step I have to do in Thevinins theorem. And my second step is, I am going to distribute the current using Kirchhoff's law. That is the second step I am going to do. Here let me start from the positive terminal. Let me take the I1 current as starting, and if it meet this branch, here I will be getting I2 current. Here the current flow will be I1 minus I2. Here the same current flows here through 2 ohm resistor, because here the circuit is open. So here the same current I1 minus I2 flows here. Again the current comes here, diverges here, and here the current flows in opposite direction to the I2. So plus I2 current goes here, and if I get I1 minus I2 plus I2, I will be getting I1. So I1 current flows here. So my potential, here I1, my potential, I have started with I1 and I have ended with the I1. So my distribution of current is right in the circuit. So second step is over. And what is the third step is, I am going to take some circuits, that is closed loops, and I am going to find the loop equations so that I will be getting the currents, that is I1, I2 and I3. So that is the third step I am going to do. So if I take this loop 1, 2, and here I can't take this loop as this is open circuit, and I can take this as a loop. So for me it's enough, because I am having I1, I2, only 2 variables. So 2 equations are enough to find the 2 variables. So if I take the equation, that is loop number 1, I will be getting minus 2 I1, and here the current flows here, and I will be getting minus 5 I2, here the current comes here, and minus 3 I1. Here the current flows in same direction, so I will be getting minus 20 is equal to 0. This will be my first equation. If I solve this, for example, I will be getting 2I1 plus 3I2 is equal to 20. Let me take this as first equation. For example, no need to waste time. So for example, let me take, I will be getting 2 equations. This is first equation, and if I solve this, I will be getting plus minus 1 into I1 minus I2. Here if I come down, minus of 2 into I1 minus I2, and here goes in opposite direction, so plus 5I2 equals 0. So if I solve this two equation, I will be getting the value of I1 and I2. Let me assume that the value of I1 is equal to 2 ampere. Let me assume that the value of I2 is equal to 6 ampere. So I have got I1 and I2 value. Let me note it down at side so that it will be useful for me. I1 is equal to 2 ampere and I have got I2 is equal to 6 ampere. So we have finished our third step. What is my fourth step is? Fourth step is what Kirchhoff said, that if I take this box, there are some circuit in this, and if I measure here, I'll be getting some voltage which is caused because of this circuit, and the resistance also I'll be getting because we have resistors here. So the resistance are caused by this circuit. So if I take the circuit and write here, let me cut short the circuit so that it will be easy for understanding. So I'll be getting the circuit like this. Terminal A and terminal B. So this is the box circuit. I'll be getting like this, and we have another resistor also at the end, that is load resistance RL, that is 4 ohm. Here the resistor here in this circuit, I have taken the sum of the resistors, and for example I have drawn this circuit so that it will be easy for you to understand. So if I take this resistor we have to assume as RTH, that is TH in the sense Thevinins. So Thevinins resistance, and this is VTH, Thevinins voltage. So here if I apply Ohm's law, what I have to find is, I have to find the current flowing through load resistance. So what is the formula of current is I is equal to V by R according to Ohm's law. So if I substitute in this, I will be getting I is equal to voltage is VTH by resistance is, we have two resistors here, one is RTH and other is RL. Finally I have got this formula, and this is, let me erase this, and this is our final or our aim to find out the current flowing through the 4 ohm resistor using Thevinins theorem. And this is the formula to find. The formula we got is current is equal to VTH by RTH plus RL. So our aim is to find, we know RL, that is load resistance, that is 4 ohm is given already. We have to find Thevinins resistance and also Thevinins voltage. Yeah, what I have to do to find Thevinins voltage? Let me take this circuit. Here I have got an open circuit. So what I am going to do is, I am going to connect this open circuit with an imaginary voltage source, and this voltage source I am going to take this as Thevinins voltage. So what I have got here is a closed circuit. Now I have to write the loop equation so that in that loop the VTH should be there, or I have to consider any one of the loop from this circuit. Here let me take the smallest loop so that I can find the current flowing through the VTH easily. Or if I take the large loop, that is long loops, I'll be getting more resistance and voltage sources, so that it will be long, it is a long process to solve. So let me take this circuit alone. So let me take this as fourth, that is third loop, and here I don't have any current flowing through this, so I'll be getting -6. Here the current flows here, it comes down, and here the current in the same direction, so minus VTH. Here the current flows here, in this direction it comes, and here I have 8 volt voltage source, so I'll be getting -8. Here if I go, the current is coming down and we have to find the voltage. Its voltage is opposite direction, so I'll be getting plus 2 into I1 minus I2. So if I solve this equation, -6 minus VTH minus 8 plus 2I1 minus 2I2 is equal to 0. If I solve this equation, I'll be getting VTH is equal to 2 by 7 volt. So now I have found VTH. I'm going to write here VTH is equal to 2 by 7 volt. Yeah. Our final step, that is fifth step, is to find RTH. So what I have to do is, let me take this circuit. What I am going to do is, I am going to reduce this circuit using some circuit methods, so that circuit reduction method, so that easily I can reduce the circuit and I can find the Thevinins resistance. Here I have got, this is 2 ohm, this is 3 ohm, here this is 1 ohm, 6 ohm, and again here 5 ohm. I left a resistor here, the 2 ohm, and this is 4 ohm. And let me reduce this circuit. See, in this loop we have, and we can see that this resistance and this resistor are in parallel to each other. Let me take this. If it is parallel, we know the formula R1 into R2 by R1 plus R2. So 5 into 2 by 5 plus 2. So my circuit will be reduced to 10 by 7. Here if I reduce my circuit, I will be getting only this. So let me write this here. I have got 10 by 7 here. And here it would be easy for us to convert the voltage sources and replacing it by the internal resistance of it. So here we have 4 volt, and here 8 volt, and here 20 volt. If I replace this with the internal resistance, here internal resistance given is 0, so I will be getting the closed circuit, that is short circuit. And if I replace here, there is no internal resistance, again this will become short circuit, and here also there is no internal resistance, so this would also become short circuit. Why I am doing this here is, it would be easy for us to calculate the resistance without the voltage sources, and here there may be any sources, that may be current source or voltage source. It's not a problem for finding the results using current source or voltage source. Here, now these two resistance are series with each other, so I have to add up. So I will be getting 10 plus 1 by 10 by 7 plus 1. So this resistance I will be getting like this. So I can close this resistance. Here this is, let me take as 13 by 7. Yeah. And here these two resistance are series. So I have to add up 6 plus 2 is 8. So I will be getting this resistance as 8 ohm. And finally this resistor is parallel with this. So 13 by 7 plus 8 by 13 by 7 into 8. Let me take some example answer so that I'll be getting only this resistor, and final answer is 26 by 9. Yeah. Now here this is load resistance RL. So my final resistor is 26 by 9. I have got this answer, and RTH I have got is 26 by 9. So if I substitute these answers here, I will be getting I is equal to, my VTH is 2 by 7 by RTH is here 26 by 9 plus load resistance is 4. So finally, this may be the open circuit. What I have made here is the open circuit. I have forgotten to tell. We can take this circuit alone. No need to add the resistor given over there, so that we can find the total resistance, that is RTH. Yeah. So my total answer is 28 by 7. Yeah. And maybe these answers I have taken an example sum. So whatever may be the circuit and wherever the current flows through the resistor, we can find. And if I want to find the current flowing through this resistor, what I have to do is, the step 1, I have to remove that resistor, that is I have to make an open circuit, and I have to assume that that resistor is the load resistance. After that I have to distribute the current using the Kirchhoff's law. The third step is to find the equations and find the currents. After that I have to find the Thevinins voltage used by assuming I am having an Thevinins voltage here, and I have to close the circuit. After that I can find the Thevinins voltage. Then I have to use the combinational circuits, and I have to reduce the circuits, and I have to find the resistance, Thevinins resistance, and we know the load resistance is already given. After that I have to substitute the answers here, that is we have found the Thevinins current I is equal to VTH by RTH plus RL. Thank you. Let me meet in my next video on Norton's theorem. Thank you.